Day 52, Honors Physics, rotational equilibrium or overall equilibrium with reference to torque and F net equals ma. Everything is at static equilibrium. So for example, like every problem, I'm drawing the main object, the beam. It's a horizontal line, that red line that I have there. And I'm drawing all the forces that are applied to that beam. So I got a 150-pound man or woman over here, I guess it's a man, circus performer, at the end. And the beam itself is 400 pounds, it's uniform, so that's dead center. 20 feet from the end, because the beam is 40 feet long, is the entire weight of the board at its center of gravity, so 400 pounds. So therefore, those are the only two forces down on the beam. There must be an upward force of 550 pounds, and I'm going to put that right at the edge of the wall where the beam would basically just barely pivot. You know, if he goes too heavy or too far, or I should say, if it's not, you're at the point at which the thing is going to start to rotate, but it's not rotating yet. So it's going to rotate on that edge of that wall at a distance of x overhang. So I've labeled that x overhang x from where he's standing to the edge of the wall. That's what we're looking for. It's a very simple problem now. You can pick any point as your reference point for calculating torque. I'm picking this point as my point of reference for calculating torque, and there's only two forces producing torque from point A. Clockwise, if I'm holding point A stationary, which is not happening in real life, but once again I'm using it as a reference to solve the problem, the 550 pounds pushing up there would make that lever, or that beam, rotate this way around with reference to point A, clockwise, with reference to point A. So that's why it's that force, 550 pounds, and you can, once again, do these in whatever units you have, as long as you're consistent, leave it all in pounds, times that distance x is the clockwise torque times the sine of 90, which I'm leaving off, equals the counterclockwise producing torque. This force here is pushing down on the lever, or the beam, trying to make it rotate clockwise with reference to point A if point A was held stationary. So that's counterclockwise, 400 times that distance, 20 meters, and it's very simple, solve for x.